When you think of progress, what comes to mind? New roads, towering skyscrapers, or advanced technology? But here's a question. Is it really progress if it costs lives or damages our planet? Safety and environmental protection aren't just buzzwords. They're the foundation of a better, more sustainable future. That's where environment, health, and safety, EHS, comes in, turning ideas into action. In this video, we'll take you on an exciting journey through jaw-dropping mega projects that prove safety and environmental care can coexist. Some of these projects will leave you amazed. Which one will impress you the most? Stay with us and find out. Fukushima Ice Wall, Japan. Have you ever heard of an ice wall being used to stop a nuclear disaster? Sounds like something out of a sci-fi movie, right? But it's real, and it's happening in Fukushima, Japan. This isn't your average construction project. It's a groundbreaking effort to contain one of the world's most dangerous environmental crises. On March 11, 2011, a powerful earthquake and tsunami struck Japan, leading to the catastrophic meltdown of 3 reactors at the Fukushima Daiichi nuclear power plant. Imagine the chaos, the destruction, and the fear of radioactive material seeping into the environment. It was a disaster on a massive scale, the kind that leaves people wondering, how do you even begin to fix this? That's where the Fukushima Ice Wall, also called the Landside Impermeable Wall, comes in. The mission? Stop groundwater from seeping into the damaged reactor buildings and mixing with radioactive material. It sounds simple, but in reality, it's a complex feat of engineering. But how do you freeze an entire underground wall of soil? Here's how it works. A network of pipes is buried underground, stretching 1.5 kilometers around the reactors and reaching 30 meters deep. Through these pipes, a coolant is circulated at a bone-chilling minus 30 degrees Celsius, minus 22 degrees Fahrenheit. This freezes the soil, turning it into a solid, frozen barrier that stops groundwater in its tracks. Picture a ring of ice beneath the ground, like a frozen fortress protecting the reactors from contamination. Pretty cool, right? But building it wasn't as simple as it sounds. Imagine working in one of the most hazardous areas on Earth, a site contaminated with radioactive materials. Every step had to be carefully calculated to keep workers safe. Tokyo Electric Power Company, TEPCO, came up with the idea, but it was Kojima Corporation, a construction company experienced in frozen soil technology, that made it happen. After years of planning, design, and careful execution, the ice wall went live in March 2016. It was a monumental achievement. But here's something to think about. Innovation comes at a cost. The total price tag? A massive $303 million, all funded by public resources. That's the price of safety, but when it comes to protecting the environment from nuclear contamination, was it worth it? Let us know what you think in the comments below. Is that a cost you'd be willing to pay? Now let's talk about the real challenge, keeping the ice wall frozen. You'd think it's set it and forget it, but that's far from the truth. The system requires constant energy to keep the ground at freezing temperatures. If the coolant leaks or a pipe fails, the temperature can rise and parts of the wall could thaw. This is exactly what happened in some sections of the wall. Certain areas didn't stay cold enough, requiring extra effort to refreeze the soil. It's like constantly patching up an ice dam to keep water from breaking through. The operation is ongoing, and it's a reminder that even the most advanced systems need continuous monitoring and care. Despite these setbacks, the Fukushima ice wall continues to play a vital role in protecting the environment. It's a crucial part of Japan's strategy to prevent further contamination. What's more, the coolant used is environmentally safe, and every effort is being made to minimize the long-term impact of the disaster. But here's a question for you. Is this approach sustainable in the long run? With energy costs, system maintenance, and environmental concerns? Do you think projects like this are the future of disaster containment? The Fukushima ice wall stands as a symbol of human resilience and the power of innovation. Faced with one of the most complex environmental challenges of our time, humanity found a way to fight back. But as we look ahead, it raises a much bigger question. Can we learn from this and develop better solutions to avoid disasters like Fukushima in the future? MOSE project, Italy. What if you had to save an entire city from sinking? Not just any city, but Venice, one of the world's most iconic cultural treasures. Sounds like a plot for a disaster movie, right? But this is real life, and the answer lies in one of the most ambitious engineering projects in modern history, the MOSE project. The MOSE project, which stands for Modulo Sperimentale Elettromeccanico, Experimental Electromechanical Module, is a bold and daring effort to protect Venice from the rising tides of the Adriatic Sea. As you may already know, Venice is a city built on water. While that's part of its charm, it's also its greatest threat. Rising sea levels, sinking ground, and more frequent acqua alta, or high tides, are putting Venice's famous landmarks, streets, and even its ecosystem at risk. But how do you protect a city that's already surrounded by water? The solution? Giant mobile barriers. And here's where things get really interesting. The MOSE system consists of massive gates located at the three main inlets of the Venetian lagoon, Chioggia, Malamocco, and Lido. These gates stay hidden on the seafloor most of the time, allowing normal water flow to continue. But when high tides are predicted, something incredible happens. The barriers rise from the seabed like a giant shield, cutting Venice off from the Adriatic Sea and stopping floodwaters from entering the lagoon. Think of it like Venice's secret weapon, hidden beneath the waves, ready to spring into action. But when exactly do these barriers activate? The system is triggered when the sea level rises above 110 centimeters. Once that happens, the barriers lift, effectively locking out the rising waters and protecting the city from potentially catastrophic floods. Imagine watching these giant gates slowly rise from the sea like something out of a futuristic sci-fi scene. It's a powerful image, and it's all happening in real life. If this sounds like an easy win, think again. Construction of the MOSE system began back in 2003, and like many large-scale mega projects, it's been anything but smooth sailing. Delays, technical issues, and political challenges have slowed progress. And then there's the cost. Originally projected to cost around 2 billion euros, that number has skyrocketed to 6 billion euros, roughly $7 billion. For perspective, that's more than triple the initial budget. But with Venice's future on the line, can you really put a price on saving an entire city? Let us know what you think in the comments. Is it worth it? But here's something you might not know. The technical challenges didn't stop once the gates were built. Some of the mobile gates have developed leaks, while others have struggled with wear and tear caused by harsh marine conditions. And since these gates are located on the seafloor, maintenance is no easy task. Just imagine trying to fix a giant metal structure while it's submerged in seawater. Constant upkeep is required to keep everything in working order. And then there's the environment. How do you protect Venice without disrupting the delicate ecosystem of the Venetian lagoon? It's a tricky balancing act. The lagoon is home to unique aquatic life and plays a crucial role in Venice's cultural and natural heritage. Any change to the natural flow of water could affect the ecosystem. Engineers have had to make sure the MOSE system protects Venice from floods without damaging the ecosystem that makes the city so special. Despite all the setbacks, there's no denying that the MOSE project is a monumental achievement. It's not just about flood protection. It's about preserving the history, art, and culture of Venice for future generations. For centuries, Venice has been a symbol of beauty and resilience. With the MOSE system in place, the city might finally have a fighting chance against rising sea levels. But wait, there's more. Like many mega projects, the MOSE system hasn't escaped controversy. Allegations of corruption and political issues have plagued the project from the start, creating delays and tarnishing its reputation. But despite the setbacks, there's light at the end of the tunnel. If everything goes according to plan, the MOSE system will be fully operational by 2025. It's been a long journey, but once it's ready, it could be a game changer for Venice. So what do you think? Could the MOSE project be a blueprint for other coastal cities facing rising sea levels? Will it serve as a model for places like Miami, New York, or Jakarta, where climate change is also knocking at the door? The Great Green Wall, Africa. Can planting trees really change the future of an entire continent? It sounds too simple to be true, but Africa's Great Green Wall is proving that sometimes the simplest ideas can have the most profound impact. Stretching an astonishing 8,000 kilometers from the city of Dakar in Senegal to Djibouti on Africa's east coast, this isn't just a line of trees. It's a bold vision to restore life to a region battling one of the planet's harshest challenges, desertification. Launched by the African Union in 2007, the Great Green Wall aims to restore 100 million hectares of degraded land by 2030. But it's more than just about planting trees. This mega project is about restoring entire ecosystems, boosting livelihoods and securing a future for millions of people living in the Sahel region. And here's where it gets really interesting. It's not just an environmental project. It's also an economic one. Think about it for a moment. Imagine an 8,000-kilometer green corridor snaking its way across 22 African countries. It's not just about the trees. It's about creating sustainable agriculture, restoring vegetation, and promoting eco-friendly land management. That's millions of jobs, fertile soil, and food security for communities struggling with poverty and climate change. And here's a stat that will blow your mind. The project aims to absorb 250 million tons of carbon dioxide. That's the equivalent of taking millions of cars off the road. But if you think this journey has been easy, think again. Transforming 22 countries' landscapes into a single unified project is no small task. It requires coordination, funding, and most importantly, people. Millions of people. The total price tag? A staggering $33 billion. And while funding pledges have been made, gaps remain. But is it worth it? We'll let you decide. Drop your thoughts in the comments. Is $33 billion too much to create a greener, more sustainable future? But money isn't the only challenge. Political instability in some of these countries has slowed progress. In regions like Burkina Faso, the presence of extremist groups has threatened the safety of workers, making it difficult to plant and maintain the wall. On top of that, climate change, the very issue this project is fighting, is making things harder. Unpredictable rainfall and severe droughts have delayed planting efforts, sometimes leaving communities struggling to meet their goals. And yet, despite these challenges, progress is being made. The heart of this movement is people, local communities coming together to take control of their future. The Great Green Wall isn't something being forced on them. It's an opportunity to create jobs, develop ecotourism, and build a sense of ownership in the land they live on. These communities are the lifeblood of the project. Without them, it wouldn't be possible. But here's the bigger picture. The Great Green Wall isn't just about Africa. It's a symbol of hope and resilience for the whole world. It's a demonstration that, even in the face of climate change, humanity can push back. It shows us that large-scale restoration isn't just a dream. It's something we can achieve if we unite with a shared vision. So here's a question for you. Can a wall of trees reshape the future of a continent? Drop your answer in the comments below. Because right now, the Great Green Wall is showing us that when people and nations work together, even the most formidable challenges can be overcome. It's more than a wall. It's a living, breathing symbol of hope, growth, and the power of unity. And with 2030 fast approaching, all eyes are on Africa. Will it inspire other regions of the world to follow suit? Kansai International Airport, Japan. What if I told you there's an airport built entirely on water? Not on the coast, but on an artificial island in the middle of the sea. Sounds impossible, right? Well, welcome to Kansai International Airport, KIX, a modern engineering marvel that stands as a testament to human ambition, creativity, and resilience. Just 38 kilometers from the heart of Osaka, this airport isn't your typical airstrip. It's built on a man-made island in the middle of Osaka Bay, a feat so bold that many thought it couldn't be done. But in 1987, construction began, and what followed was one of the most challenging infrastructure projects the world had ever seen. The first challenge? Creating an island that wouldn't sink. Engineers built a massive seawall made of rock and a staggering 48,000 tetrapods, those funky-shaped concrete structures designed to break up waves. But that was just the beginning. To form the island, millions of tons of earth were dredged from Osaka Bay and nearby mountains and poured into the area. This wasn't a quick fix. It took 4 years to stabilize the seabed, By 1991, the ground was strong enough to start building Terminal 1, and here's where it gets even more impressive. The terminal, designed by world-renowned Italian architect Renzo Piano, stretches 1.7 kilometers long, making it the longest airport terminal in the world at the time. If you think walking through a regular airport is exhausting, imagine walking through this colossal structure. By 1994, Kansai International Airport officially opened its doors to the world. But this isn't just an airport, it's a global gateway. With two massive runways, 3,500 and 4,000 meters long, it handles everything from jumbo jets to budget airlines. Terminal 1 is a masterpiece of design, while Terminal 2 caters to low-cost travelers. In 2019 alone, KIX saw nearly 32 million passengers, making it Japan's third busiest airport. Kansai International Airport isn't just about flights, it's about connections. It's a major hub for airlines like ANA, JAL, and Nippon Cargo Airlines. And it's also the home base of Peach Aviation, Japan's first low-cost airline. The connections don't stop there. Getting to KIX is seamless, thanks to the Kansai Airport line, ferry services, and major roadways. Whether you're flying in, taking a train, or hopping on a ferry, KIX is built for efficiency. But here's something you might not know. This airport isn't just big, it's sustainable too. From energy-efficient systems to waste reduction initiatives, KIX shows that even mega projects can care for the planet. It's a reminder that progress and sustainability can go hand in hand. Of course, building something this ambitious wasn't cheap. The original estimate was $14 billion, but by 2008, the final price tag hit a whopping $20 billion. Why? Because building an island in the sea is never simple. The island started to sink, literally. Land subsidence was one of the biggest challenges engineers faced. But instead of giving up, they adapted. With continuous adjustments and new engineering solutions, KIX found ways to control the sinking. And if you think that's impressive, here's something even more shocking. The airport withstood the 1995 Kobe earthquake without significant damage. A magnitude 6.9 earthquake rocked the region, but KIX remained standing, proving that this island was built to last. Now fast forward to today. As the world gears up for the Osaka Kansai Expo 2025, Kansai International Airport is getting a major upgrade. Renovations are already underway to ensure the airport can handle the influx of global visitors. Imagine the energy and excitement as people from around the world flood into Osaka. KIX won't just be an airport, it'll be a welcome mat for the world. So next time you're walking through Kansai International Airport, take a second to look around. You're not just standing on concrete, you're standing on a man-made island that defied the odds. You're part of a story of ambition, creativity, and resilience. It's not just an airport, it's proof that when humans dare to dream big, we can build the impossible. Thames Barrier UK. What if I told you there's a 3,300-ton steel gate lying quietly on the riverbed, ready to rise at a moment's notice to protect one of the world's most iconic cities? Sounds like something out of a sci-fi movie, right? But this isn't fiction, it's real. Welcome to the Thames Barrier, London's mighty protector, and one of the most impressive flood defense systems in the world. Have you ever thought about how a historic, bustling city like London protects itself from devastating floods? With the River Thames flowing right through the heart of the city, the stakes couldn't be higher. The answer lies just 2 miles east of the Isle of Dogs, where 10 massive steel gates stretch across the River Thames. And since May 8, 1984, these gates have been quietly doing their job, day in, day out. But here's where things get really interesting. Each of these gates weighs a staggering 3,300 tons. To put that in perspective, that's about the weight of 20 blue whales per gate. Most of the time, these colossal gates lie flat on the riverbed, allowing the Thames to flow freely. But when a storm surge or high tide is on the horizon, these gates rise up like a fortress, forming a giant steel shield to hold back the water. If you're picturing something like the scene from a sci-fi blockbuster, you're not far off. Except this time, it's real. The Thames Barrier's role is nothing short of monumental. It protects 125 square kilometers of central London. That's roughly the size of 17,500 football fields. But it's not just about numbers. It's about 1.42 million people, 4,000 historic buildings, and critical infrastructure like hospitals, subway lines, and transport hubs. If you've ever visited landmarks like the Tower of London or the Houses of Parliament, you've seen the very places this barrier was built to protect. Imagine that for a moment. Without it, these world-famous sites could be underwater during major storm surges. But how did it all begin? The story of the Thames Barrier starts with a disaster. In 1953, a catastrophic flood swept through London, causing widespread devastation and tragic loss of life. It was a wake-up call. London needed a solution, and not just any solution, a solution that could stand the test of time. Construction began in 1974, and after a decade of planning, building, and testing, the Thames Barrier was completed in 1984. It cost £534 million at the time, which is roughly £1.6 billion in today's money. Expensive? Yes. But how do you put a price on protecting a city like London? Since then, the Thames Barrier has proven itself time and again. It's been deployed more than 221 times to defend London from floods. Think about that. 221 times this mighty fortress has stood between London and disaster. It's not just a wall, it's a living, breathing system that adapts to the ever-changing climate. But how do you keep something this big, this complex, ready for action? Well, the Thames Barrier doesn't just sit around waiting for a storm. It's tested once a month to ensure everything works perfectly. This regular testing isn't just for show. It's a crucial part of the system's maintenance, especially as climate change makes storms and sea level rise more frequent. Think about it. The very threat the barrier was built to fight, rising sea levels, is now happening faster than ever. Looking ahead, engineers are already planning for the future. The Thames Barrier is expected to safeguard London until 2070, with a full review scheduled for 2040. But what happens after that? Will we see bigger, smarter, more advanced flood defenses in the future? Will they be controlled by AI, or will they look like something straight out of a futuristic movie? What do you think? Drop your thoughts in the comments below. We'd love to hear your ideas on what the next generation of flood barriers could look like. The Thames Barrier isn't just an engineering marvel. It's a quiet hero. It doesn't boast. It doesn't shout for attention. It lies in wait, unseen beneath the surface, ready to rise and protect. Next time you're walking along the River Thames, take a moment to think about the invisible force protecting the city. It's not just a structure, it's a lifeline, a symbol of human resilience and ingenuity. It's proof that, when humans work with nature instead of against it, we can achieve the impossible. And as climate change continues to shape our world, one thing is clear: London's protector, the Thames Barrier, will keep rising to the challenge.